After studying about the electric field intensity on the axial line of the electric dipole, now let's move on to find the electric field intensity along the equatorial line of an electric dipole. Now, these 2 points, that is along the axial line and along the equatorial line, both are very important for your exam purpose. Okay, now let's move on to the second part, that is equatorial line. Now, the first point is that first let us understand what is this equatorial line. This line basically comes from the word equator. In the globe, you have seen the equator, it divides the earth into 2 equal parts. Same is applicable for the equatorial line also. In this condition, this equatorial line divides the electric dipole into 2 equal parts. That's why it is called the equatorial line. Now, how it is done, let us understand by a very small diagram. In this condition, let me first draw the 2 dipole. This is first dipole and this is second dipole. These 2 dipole have their different charges. This first point, let's mark it as A, and the second point, let's mark it as B. The first point have a charge that is minus Q and the second point has a charge that is plus Q. So they form the dipole. Okay, the dipole is separated by a particular distance and the distance between these 2 dipoles is given by 2L. So this is all we know. Let's move on to equatorial word. In this condition, the equatorial line divides the dipole into 2 parts, as I've already told you. So between A and B, there is a bisector. Okay, this bisector divides A and B into 2 equal parts. That is, this part has a length L and this part has a particular length L. And along this equatorial line, so this becomes the equatorial line because it divides A and B into 2 equal parts, so it becomes a bisector. And along this equatorial line, let's say we mark a point which we called capital P. Now, this is the diagram. You have to find the electric field intensity at the point P, and the point P lies on the equatorial line. Now, if you look at this diagram, so if I connect A and P and if I also connect B with that of P, so it becomes a particular triangle. Okay, in this condition, if this angle is theta, then this angle is also theta because this is a bisector. Okay, let's mark it as O. So OP becomes a bisector of the triangle A, B and P. Now let's work upon it. First, you have to find the electric field intensity across every identical charges. Okay, now let's work first with the point B. The point B has a charge plus Q. So you have to find that this plus Q is exerting a particular electric force at point P. And what is that electric force? It is repulsive in nature. This is denoted by, let's say, E1. So E1 basically becomes a repulsive in nature and it directs P away from the point B. So it is moving away from B. Okay, now consider the second case. At A, there is the charge minus Q. The minus has a property to attract the objects. In this condition, if I ask you that what is the electric force created by point A at point P? So in this condition, it is attractive in nature and the arrow shows that point P is directed towards the point A. This arrow is given by a vector, let's say, E2. So E1 is the electric field intensity which is created at point P by plus Q charge, and E2 is the electric field intensity which is created at point P by minus Q charge. Now, let us simplify it. E1 and E2 are the 2 vectors, so the resultant of the 2 vectors is given by capital E. Okay, so this becomes a resultant of the vector which is found by the parallelogram law. If I complete this figure, so it becomes a parallelogram and E becomes a diagonal of a parallelogram. In this condition, let us resolve E1 and E2 into 2 corresponding parts. That is, if I resolve E1 into vertical component and the horizontal component, so in the vertical component like this, This is the vertical component for even. For resolving, first you have to check the angle between a particular vector that makes with the x-axis. So first you have to find the angle of even with that of the horizontal axis. So what is this angle? Now look at this diagram. In this diagram, angle PBA is theta. This angle is theta. So this angle also becomes theta, which is your corresponding angle. You can see that this is your one line and this is your another line. So when the bisector is drawn between two parallel lines, then they become a corresponding angle. You can also understand it by this simple diagram. Okay, these are the two parallel lines, and if any bisector or any line is drawn cutting these two parallel lines, in that condition this is theta, so this angle also becomes theta. So referring this diagram with that of this, it also becomes theta. Now I told you that after finding the angle, you can easily resolve any vector into its two components. So even now in the vertical axis, it becomes even sine of theta, and along the horizontal axis, it becomes even cos of theta. Apart from that, now let's work upon E2. Similarly, you have to resolve E2 into two components. That is, now E2 is resolved into the vertical axis. That is, the vertical axis is directed downward because E2 is also directed downward. First, let's check the angle that E2 makes with that of the x-axis. So this angle you have to find. Again, look at the diagram. Okay, this angle is given to you theta. Similarly, this angle now also becomes theta. How? This is the alternate angle. So in this condition also, this angle PAB becomes equal to the angle which E2 makes with that of the x-axis. If the angle is known to you, you can easily resolve E2 into two components. So it becomes E2 sine of theta, and along the horizontal axis it becomes E2 cos of theta. Now my work is done. All the components are resolved. You have to find EY, that is the resultant along the y-axis, and EX, that is the resultant along the x-axis. Now let's start with it. So now let's find what is E1 and what is E2. So similarly, the formula for E1 is K, which is a constant, Q upon R square. R. In the case of E1, R is the distance between point P and point B. So we can write it as BP square. Now we have to work upon how to find this BP. In this condition, let's again move on to the diagram. Now in this diagram, you can see that AB is given a total distance, that is 2L. And now this point P is at a particular distance from the electric dipole, and this distance, let's say, is given by small r. So this distance becomes small r, that is OP, the distance becomes small r. This is a 90 degree, okay, this is 90 degree. So in the condition, if you have to find BP, so you have to refer the triangle POB. POB. Now look at this triangle. POB is a right angle triangle, and using the Pythagoras theorem, you can solve the value for BP. How to solve? BP is a hypotenuse. So going to the condition, it becomes BP square is equals to OP square plus OB square. What is BP square? BP square, the value for OP, I'll just tell you that it is R square, plus what is the value for OB square? OB becomes half of 2L. So it becomes L square. Now the BP square becomes R square plus L square. Substitute this value here. So it becomes KQ upon R square plus L square. This is one E1. Okay. Now let's move on to E2. E2 also have the similar formula, that is KQ upon E2. This is E2 and it basically produces between P and A. So the distance between them is AP whole square. Now, this is not a vector quantity. This is only a magnitude. So you are not going to consider the sign of it. You are going to consider only the magnitude of a Q. Now, KQ, it remains constant. AP. In the triangle, you can see P PAO. That is, in the triangle PAO, this is also a right angle triangle. Working on the similar concept, you can get that AT square now becomes R square plus L square. Similar concept that we have already worked upon. So substituting the value, it becomes R square plus L square. Now, we have already resolved E1 and E2 into their horizontal and vertical components. Now you have to find EY. EY is the resultant of the vector E along the y-axis. What is your y-axis? Y-axis is your vertical axis. Now, in this vertical axis, you can see there are two vectors. First is E1 sin theta and other is E2 sin theta. E1 sin theta and E2 sin theta both are in the opposite direction. So, in that condition, it becomes E1 sin theta minus of E2 sin theta because the direction is opposite. Now, look at the value. E1 and E2 both have the same value and it is multiplied by the same coefficient, that is sin theta. So, in this condition, they get cancelled out and you will get EY, that is 0. Similarly, work upon EX. EX is the resultant of the vector E along X direction. So, this is your X direction, that is horizontal axis. What are the vectors that lie in this X direction? First, the vector is E1 cos theta. Another vector is E2 cos theta. So, now put the value E1 cos theta in the same direction. So, the value get added up. That is E2 cos theta. Now, E1 is known to you, E2 is known to you, but cos theta is still unknown. How this cos theta is known? We again have to refer the same diagram. Now, in this diagram, you can see, let's say, we talk about triangle PAO. In triangle PAO, we have to work upon cos of theta. So, what is cos theta in this condition? This angle is theta. Cos theta is given by base upon hypotenuse. Now, in the triangle PAO, what is base? The base is AO. So, the base is AO. Hypotenuse. What is hypotenuse? It is PA. Now, referring from the figure, put the value directly here. That is, cos theta is equals to, what is AO? AO in this condition is L. What is PA? PA we have already calculated out, that is, PA square is equals to R square plus L square. So, PA now becomes under root of R square plus L square. So, it becomes under root of R square plus L square. Substitute this value directly into the equation, you will get your answer. Now, take cos theta common because it is common in both the cases. So, it becomes E1 plus E2. E1 and E2 both are known to you, so the value get directly added up. Cos theta, substitute the value from there, that is L under root R square plus L square multiplied by, when you add these two values, you will get the answer, that is KQ upon R square plus L square. Now, solve this value and multiply these two equations, you will get your answer, that is 2KQL upon R square plus L square 3 by 2. So, now this is your answer, that is, it is EX. Now, you can see that this EX, okay, this is EX along the horizontal axis and this is similar to the vector E, that is your resultant at point E. That means EX is equals to the E vector, that is the electric field intensity at point P. So, EX and E both have the same value and the formula for it 2KQL upon R square plus L square 3 by 2. Now, let's convert this particular formula, that is the electric field intensity at point P, in terms of a vector quantity. And before proceeding further, let's modify this formula into a very simple one. Now, this 2 and Q and L, 2QL, it becomes a part of a formula that we have already discussed, that is a dipole moment. So, this formula reduces into KP upon R square plus L square 3 by 2. Now, if we have to convert this into vector quantity, that is the electric field intensity into a vector quantity, so we have to multiply this whole equation by a unit vector. So it is multiplied by a unit vector of a dipole moment. So this is how it is multiplied. Now you can see here a unit vector multiplied by a magnitude of that particular vector, it becomes a vector. So this formula reduces into K P of vector upon R square plus L square 3/2. Now, there is a very important point and a very common case. We can say a very important case also. Now, it states